independent random variables. Now, yesterday we talked about the expected value, the mean of independent random variables. So that was yesterday, and today we're going to talk once again about the standard deviation. So just as a reminder, you're going to see this idea around the variance of x. So just as a reminder, or in terms of review, the mean of x is equal, is the same thing as the expected value of x. And the standard deviation of x squared is what we refer to as the variance of x. So you might see this in some notes or some materials. We're going to mainly be utilizing in our course these notations in here. They both mean the same thing. The idea here, though, is how do we work with them? And the standard deviation is something that's very, very important. As such, the standard deviation of x is the square root of the variance of x. Now, standard deviations are trickier than means. Remember that. One of the key things to doing these types of problems is to remember that standard deviation doesn't work like the normal pieces. So when we talked about transformations and we shifted all the data, we said that the standard deviation stayed the same. It's those concepts that are still going to be here, and you will say, oh, if I take away 5 from every single value, what happens to my standard deviation? And if you remember, that's just shifting the distribution over, which means that the spread of the data is still the same. That's the same thing that we're going to do today. And if we multiplied, the standard deviation was multiplied as well. So it's equal, sorry, I meant to write it up here as well. Standard deviation of x. So the first rule that we have is on those first two rules. So the standard deviation of the standard deviation of a times x, in other words, it is a constant multiple is exactly what you think it is. All right. So we say that the standard deviation of a times x is equal to a times the standard deviation of x. How does everybody feel about this notation? I'm going to try to focus a little bit more on just the sigma notation with using the information of the operation as a subscript. Does this feel comfortable for people? I haven't done it, and I usually try to go of the one on the left, but I found that writing multiple letters and having that type of period often confuse people. How do you feel about this one right here? Do you have feelings? Or are you just dead inside? Can you hear me? A little worried over here. It's like, oh well. This is the notation that I think will be very good to see. Now, the next rule is when we take the standard deviation and we have x and we add or subtract some constant. In other words, we're going to see this as x plus or minus a constant. This is equal to the standard deviation of x. This is the idea of shifting. So the idea here is that if we just add or subtract, there's no change in spread. There's no change in spread if we just add. So for, we did this before. If I were to add $5, if I charged everybody $5 more, or if we're playing a game and we're talking about how much you won, and I say, you know what, you guys have been doing really good. I'm going to give you an extra dollar. I'm going to increase all the payments by $1, all the winnings by $1, all the outcomes by $1. If I were going to do that, the expected value would go up by $1, just like we would think it would. But the key here is that the standard deviation would still not be changed. The spread amongst the values would still stay as what it was. Does everybody understand those two rules? Does anybody not need more clarification for these two rules? Okay, good. And it should be noted that the standard deviation of AX plus or minus C would therefore just be A times the standard deviation of X. So you can combine these as such, where X is the random variable. So the only random variable here is X. When we're dealing with a single random variable and we're talking about one single outcome, that's our sigma. Now, the trickier part occurs. The main idea here is we're going to talk about combining independent random variables. So we're combining independent random variables, and there'll always be independent. You can talk about if they're not independent, there's different formulas that you can utilize, such as the correlation in the calculations, but that is something that is in very high order statistics that's not within our course. So in this case, X is a random variable. Y is a random variable. And as I noted, x1, x2, x3 denote separate random variable instances. This idea of x1, x2, x3 is the hardest part to understand on this. But there's a very major concept that happens inside in statistics that's really important. If you are thinking about investing money, or you're thinking about gambling, hopefully that's not what it is, but if you're thinking about doing something that it's going to be investing, or the idea of what happens when you play the game independently is very different. So there's a huge difference. So make sure that you understand the difference of, if you have a game and you have two choices. So the game costs minimum $1 to play. All right. You have $3. Your choices are to play the game 3 times for $1, or play the game once for $3. All right, and the concept here that I'm trying to teach you is this basic idea right here. All right, you can play the game 3 separate times. All right, so this game has an expected value of X. This game has a standard deviation of X. So, the mean of x, this is expected value of x, and the standard deviation of x is the standard deviation of x, the mean of x, expected value. We know this. If we play the game, if we play the $3 game, then that means my game, we can play it as, we can say that, we will use the notation in that, you know, I might say t for 3, or I might say something like y equals 3x. Okay, I'm going to play the game one time, but I'm going to triple down my bets. All right. Well, the mean of 3x would be just 3 times the mean of x. The standard deviation of 3x is equal to 3 times the standard deviation of x. So nothing really eye-popping in that scenario. And this is kind of like the idea of putting your eggs all in one basket. All right. So conceptually, this is what it means. Like, if you had $3 and you had $3 to gamble or invest, if you put it all on one thing, one stock, then you could either win big or you can lose big, or lose. There's a potential that you can win a lot or lose a lot. That's the potential. All right. But on average, you're gonna win. You're gonna expect it is 3 times whatever the expected is. $1 gain 3 times is the idea that they're separate. In this case, we say y is equal to x1 plus x2 plus x3. And you're saying, well, why isn't that just 3x? It's because each game is independent of the other. Each outcome does not depend on the previous outcome. Whereas in the other situation, it's only one single outcome, and your winnings for all 3 of your dollars matters on just one time, on one thing. Whereas in this case, you have it right here. And so the nice thing here is that the mean of x1 plus x2 plus x3 is equal to 3 times the mean of x. That doesn't change. Nothing weird there. But the standard deviation of x1 plus x2 plus x3 is not the standard deviation of x. But here's the big kicker, and I'm going to kind of say this. What happens is, if you play the game 3 separate times, do you think the standard deviation will be smaller, bigger, or the same as playing it just $3 bet? Do you think you're going to have more variability, less variability, or the same variability? And I think hopefully none of you say the same, because I said it's a little trickier. What do you think will happen to the standard deviation? Do you think it's going to get bigger or smaller? There's no wrong answer. You don't know the answer. I haven't taught you it. I just want to see what you think. Smaller, okay. Anybody else? Agree? Do anybody else think it's going to be smaller? Does anybody think it's going to be bigger? There's no wrong answer. I just want to hear responses. Should I just kick everybody else out of the class? Nobody else is here? You're not listening?
I agree with Tyler.
You agree with Tyler? Okay, thank you. Anybody else? Come on, let's get some responses in here. I don't want to have to check and make sure that you're just not logging in and walking away, because when I hear nobody answering, and there's only like 2 people answering throughout the entire class, that makes me worry that the other individuals are just turning on their screen and walking away. If I have to start enacting something where I'm going to check in midway and see if you are, and if not, boot you from the class and count you as absent, I think I'm going to have to get to that part, especially when you're not doing the homeworks. So please, let's get some more responses. You can put me a direct message to me. I got 4 responses so far. There's 15 of you here today. the answer here is, thank you for those of you, everybody else here that is still within the class have responded. We need to get response here. We're an AP class. We have a lot of topics in here, and this is a very major type of topic right here. And so the answer is, it's going to actually be smaller. And this is a very, very big concept in statistics, that if you decrease, you can decrease the variability when you have independent variables. So it's often a multiple choice question, and the question will ask you, what's the standard deviation? And you go, well, wait a minute. If I just did the standard deviation 3 times, I'd get like 15. But I know that when I do this, my answer is going to get smaller. And so my standard deviation, if I look at the option choices, typically I can eliminate 2 of the choices. And I know my answer is going to be smaller than if it was 15, for example. And so the question is, so what's the formula? How do we do this? So the answer is smaller, but how do we do this? Before we get there, that's the main premise, is that we decrease the variability. And well, let's start off with 2 variables. So the question is, why? Okay, so we're going to try to answer that. So first off, there's a formula. And it says that, well, the idea is that when combining 2 random variables through addition, we have something we cannot add standard deviations. We cannot add standard deviations. It's the variance that is added. So what's interesting here, and this is basically what it says. It says that the variance of of x plus or minus y is equal to the variance of x plus the variance of y. So first and foremost, variance of x plus or minus y will always be greater, or sorry, this is a very important piece right here. The standard deviation of x plus or minus y will always be greater than the standard deviation of x, but less than the standard deviation of x plus y. So what I mean here is that you can't get a negative. You cannot get a negative standard deviation. So if I do minus, you got to remember, well, I can't get a, so if I had 2 standard deviations, one is 3, one is 4, and I combine these, all right, I know for a fact that my answer cannot be less than 3, okay? And my standard deviation is not going to be more than 7, all right? If I go, well, if I add these 2, I get 7, but I know my answer is not 7, because when I combine them, I know that I get less variance. So we don't simply add. So when we're trying to figure out about the adding, this is typically what's going on. But in reality, the way I want you to remember is what is known as the Pythagorean relationship. Of standard deviations. And basically it says this. If I have the standard deviation of x plus y, it holds the relationship like this. I'm going to put a minus. Doesn't matter if I do it adding or minus. And so what this does is it gives me my formula for the relationship for standard deviations. It's a Pythagorean relationship. It's not a linear relationship. And as such, this says that the standard deviation of x, doesn't matter if it's plus or minus y, because I could draw the triangle, for example, like this, right? Squared is equal to the standard deviation of x squared plus the standard deviation of y squared. That is our relationship. And then, therefore, the standard deviation of x plus or minus y is equal to the square root of the standard deviation of x squared plus the standard deviation of y squared. And that is my formula. Now, this relationship holds true if we have multiple variables. So in the previous example, we did the standard deviation of x1 plus x2 plus x3. And so my relationship that I need to understand is, okay, this is what I want to find. So what I do is, I know if I square this, then this is equal to the standard deviation of x1 squared plus the standard deviation of x2 squared plus the standard deviation of x3 squared, which in turn gives me 3 standard deviation of x squareds. Because the standard deviation of x1 is a standard deviation of x. And therefore, my answer for the standard deviation of x1 plus x2 plus x3 is equal to the square root of 3 standard deviation of x squared. And that's how I do it. I'll show you an example, don't worry. The key here is always to find the square. So always think Pythagorean. So when you're doing your work tonight, think Pythagorean. Now, recall that constants do not matter. All right, so first and foremost, that if I was, remember, if I have the standard deviation of x plus y minus some constant c, let's say some constant, I want to first and foremost note that this is equal to the standard deviation of x plus y. The constant doesn't do anything. All right, so when you're doing it, you're going to go like this, and you go, okay, the constant doesn't matter. I'm gonna remove that because the standard deviation of x plus y minus a constant is going to be the standard deviation of x plus y. Then what you're going to do is you're going to say, oh, okay, if that's true, then the standard deviation of x plus y squared is equal to the standard deviation of x squared plus the standard deviation of y squared. And then you can finish it off that the standard deviation of x plus y is equal to the square root of the standard deviation of x squared plus the standard deviation of y squared. This is the easiest way. So the question that was brought up, that someone brought up, is, isn't square root and square cancel each other out? Aren't they opposites? They're called inverses, to be more technical. And so this turns out to be the square root of 3 times the standard deviation of x. That was a terrible sigma symbol. This is what it turns out to be. I don't want you to try to rewrite it this way directly because people get confused. But to bring up what the question said, the question that was brought up in my chat to me was, aren't the square root and squares opposite? And the answer is yes. But mathematically, and because I know, if we can make a lot of silly math mistakes. A lot of people, for example, will cancel out the square root and then turn it into a regular 3, but it's actually square root of 3. And so in this situation, we get square root of 3 times the standard deviation of x. Square root of 3 is like what? What is the square root of 3? Square root of 3 is 1.7. So you get like 1.7 standard deviation of x. Now, when we did it again 3 times, we got 3 standard deviation of x. And now my standard deviation of x is only 1.7 standard deviations of x's. So it decreases. It went and got smaller by that one. But don't worry about that. Yes, they cancel out, but there's a lot of bad math that happens. People will try to cancel each other things out. Like, for example, people will do this. Oh, well, those all cancel each other out. No. That's bad math. All right. So you don't do that. You want to try to add it together and then take the square root, as you'll see in the practice. Don't try to cancel out the square root. Let the calculator and technology do it for you. Okay. So the big one is for something like, what happens if I want to find a standard deviation of AX plus BY? Okay. Well, in doing this, I would do, just like I said, the first thing you want to do is use the Pythagorean relationship. So this is equal to the standard deviation of AX plus BY squared is equal to the standard deviation of AX squared plus the standard deviation of BY squared. So this idea of squaring it, Pythagorean, in every problem in your homework, you want to square it. Therefore, the standard deviation of AX is A times the standard deviation of X squared plus the standard deviation of BY, which is B times the standard deviation of Y squared. And therefore, the standard deviation of AX plus BY, and I could have put a minus there. I want you to note that if I put a minus right here, you get the same exact answer and the same exact problem. Doesn't matter if it's a minus, you still plus it because it's a Pythagorean relationship. And so I get that this is equal to the square root of A standard deviation of X squared plus B standard deviation of Y squared. Finally, the hardest one that I get people that are doing is what happens if I had the standard deviation of x1 plus x2. I'm going to do the x variable twice independently plus 2y. Okay. Well, what do I want to do first? What do I want to do first to solve for standard deviations? What's the key word that I have to remember? Or the key word, the key relationship? No, the relationship. What is it? No. The word I'm looking for is one or two different words. I either want you to remember Pythagorean or I want you to remember squares. So that's what you need. That's what needs to pop in your mind. Standard deviations. When you're combining standard deviations, you got to think Pythagorean or you got to think squares. And what I mean by that is I'm going to say standard deviation of x1 plus x2 plus 2y squared is equal to the standard deviation of x1, and actually I'm gonna replace the x because it's just standard deviation of x squared plus the standard deviation of x squared plus 2 standard deviation of y squared. All right, now what happens with those standard deviations of x's? How many standard deviation of x squareds do I have? How many standard deviation of x squares do I have?
3.
On the right-hand side of the equation.
2.
2. So I get 2 standard deviation of x squared. Now, if you want to just add them separately, please feel free. But I have seen problems where it's like x1 plus x2 plus x3 plus x4 plus x5. I think I deleted that problem from your homework, but if that is, you would get 5 standard deviation of x squareds plus parentheses 2 standard deviation of y squared. The parentheses are going to matter. And therefore, the standard deviation of x1 plus the standard deviation of, standard deviation of x1 plus x2 plus 2y is equal to the square root of that. And all it becomes is plugging in. All it becomes is just plugging in the numbers. And you're going to be given what the standard deviation of x are and what the standard deviation of y are. You'll be given that information. All right. Ready for example? And we got 9 minutes. So in your homework, I basically you only have to note the standard deviation. They're going to give you the mean and standard deviation, so it's just going to look like the previous problem. So in this problem, though, I'm going to tell you that the standard deviation of x is 5, and the standard deviation of y is 3. I'm going to give you those. Just on your homework, it looks like the table, just like you did last night. I want you to know that. And the first one, I want you to find the standard deviation, and this is pretty much instructions from tonight's homeworks. Same problems to standard deviation of each of the following transformations. Basically, you have 3 problems, and they're going to give you a mixture. And so my first one will do 2x. So that's a nice, easy one. I think nothing different about this part right here. 2x should be really nice. And so what I mean by this is the question that you're answering, what is the standard deviation of 2x? Now, we're not adding, so there's no Pythagorean. It's only when you add you get Pythagorean. Only adding. So there's no adding on this one. So that means that this is equal to what? Multiplying works like multiplying. So the standard deviation of 2x is equal to 2 times the standard deviation of x. And maybe you guys had this in your head already. This is 2 times 5, which gives me
10.
And that's my answer. Nothing really special about that question. B, x plus y. Now, what do you think the number one mistake people get in trying to figure out the standard deviation of x plus y? And I do want to note that you might see the question written like this. You might see standard deviation of x plus y. I'm using the standard deviation of x plus y using subscript notation. They mean the same thing. In case anybody does x plus y with the SD, it's the same thing. I know I'm combining standard deviations. What do you think the most common answer is that is incorrect? If you would just look at the question and what was given to you, what do you think people are going to put down as their answer? A lot. What do you think people are going to do a lot in trying to find a standard deviation? What do you think the answer that they're going to say is?
2.
No. Opposite way, opposite way. Can't get smaller. You can't be less than 3. So you know the answer cannot be less than 3. Okay, well, yeah. The biggest answer people are going to say is 8. They're just going to try to add the 2 standard deviations. What is the standard deviation of x plus y? Oh, well, I know the standard deviation of x is 5 and the standard deviation of y is 3. So 5 plus 3 is 8. And they'll say 8. and that's wrong. We know our answer has to be less than 8 because of the Pythagorean relationship. But it's also got to be bigger than 3. So we always know it's somewhere between 3 and 8. So when I do this, I'm going to go, all right, when I start this problem, I'm going to say, well, I can't directly find this. So it's the standard deviation of x plus y squared is equal to the standard deviation of x squared plus the standard deviation of y squared. And then we just, boom, okay, now I can just input the numbers. All I got to do now is input the numbers. This is what I'm trying to solve for, all right? This is what I'm trying to solve for. So I now have the standard deviation of x plus y squared is equal to, what is the standard deviation of x? 5 squared plus 3 squared. Now, if this was you with your calculator now, you can just type this in. I like to type this. I like to do the right-hand side. I can do it in my head. Use a calculator. 5 squared plus 3 squared is 25 plus 9, which is 34. Now, is 34 my answer? Yes or no?
No.
No. That's way too big, right? I know it has to be less than 8. So 34 might be another option. And so that is equal to the standard deviation of x plus y squared. So that means that the standard deviation of x plus y has to be equal to what is the answer? Simple algebra. There we go. The square root of 34. Boom, done. And if you plug in the square root of 34 into your calculator, you get a number just less than 6, something like maybe like 5.9-ish, 5.85, something around there. It's close to 36, so I know it's a little bit less than the square root of 36, so it's a little bit less than 6. So if I was just doing this and I didn't have a calculator, I go, well, my answer is going to be a little bit less. Well, there's only one multiple choice answer that's like 5.8 or 5.9. That has to be the option. And of course, you have your calculator available. You can also plug it in. Okay, we got time for another example. Like I said, let's do x1 plus x2 minus y plus 8. All right. So we want to find in this problem the standard deviation. And this is what you're doing in your homework tonight, over and over. x1 plus x2 minus y plus 8. Now, before I go forward with anything, I want to note that this 8 does not matter, so this is going to be equal to the standard deviation of x1 plus x2 minus y. The plus 8 does not matter. It does not affect. It's a constant addition. Adding constants does not do anything for my Pythagorean triangle. All it would do is take my triangle and shift it up or down, left or right. It doesn't really, however you think about it. The constant doesn't do anything. So now I'm just left with this. So the constant doesn't change it. Now I got the standard deviation of x1 plus x2 minus y squared. I'm going to square it. The Pythagorean theorem is equal to what? I take each piece and I square them and I add them together. So what do I get? I'm running out of time. I have to go do it because I had all that other time I had to deal with individuals not actually here. Standard deviation, and I'm just going to call it x because x1 is, I could put it as x1 squared plus the standard deviation of x2 squared plus, now that's a big important plus right there, the standard deviation of y squared. Now, if you wanted to, you can just treat those as a, plug them in. You can do 5 squared. If you wanted to, you could do 5 squared plus 5 squared plus 3 squared. You could do it like that. And actually, typically, I do that. So this is 5 squared plus 5 squared plus 3 squared. That's what? 25 plus 25 is 50 plus 9, so I get 59. So the standard deviation of x1 plus x2 minus y is 59. Squared is 59. So that means my answer is what? That's my answer. Come on, we're already a minute over. Ah. What's the last answer? What's the answer? Quick, just easy. Square root of 59. I wanted to note, just the last thing I wanted to note is you could have said that this is 2 times 5 squared plus 3 squared. So you could have said 2 times 5 squared, because 5 squared plus 5 squared. But in reality, I think it's easier just to do 5 squared plus 5 squared and then plus the 3 squared. There you go. That's all I have for you. Knock out that homework and get it done. I'll see you tomorrow.